Okay, we have one theorem in this section, and the theorem is regarding the relationship between the perimeters in similar polygons. So the theorem says if two polygons are similar, then the ratio of their perimeters is equal to the ratio of the corresponding side lengths. So what this is saying is that the ratio of their perimeters is basically the scale factor. So I'm just going to abbreviate scale factor with SF a lot. So let me just take this example here from red to blue. So let's just say the blue one is twice the size of the red one. So like let's say, I'm going to say that KL, if I double KL, I get PQ, okay? So let's just pick different numbers. Let's say LM is 2. That means QR is 4 since it's double. NM, I'll just make it 3. SR would then, of course, be 6. And then 4 and 8. Clearly, it's not drawn to scale, but I'm trying to just prove a point to you. So, scale factor. Now, if I'm trying to go from 1 to 2, so obviously that is a doubling effect. All right, so I would say that my scale factor here is 2 over 1, or 2, because I should be able to take the red one and multiply by the scale factor to get all of the blue lengths. So let's look at the perimeter of each separately. So if I take the perimeter and I add all these sides together, 1 and 2 is 3, plus 3 is 6, 7, 8, 9, 10. Do the perimeter of the blue one. 2 and 4 is 6, plus 6 is 12, 12 and 8 is 20. So look at the, if I put the ratio of the perimeter, or put the perimeters into a ratio, do you see how I just get the scale factor? So what this theorem is saying is, what if I don't know all the side lengths? What if I just was told the two shapes are similar, the scale factor is 2, and the perimeter of the red one is 10. What's the perimeter of the blue? You would be able to say it's 20 because it's got the same scale factor. All right, so this will come into play in a few examples here. Okay, number 3. Triangle UVW is similar to YXW. Okay, so right there, what I'm thinking about is, okay, that means, number 1, corresponding angles are congruent, and number 2, the corresponding sides are proportional. Find the value of A. So I'm going to write a proportion here. I'm going to set the two sets of corresponding sides equal that I'm given. So if I am given A, which is on UW, so UW is the first and the last letter. It corresponds to YW. So I'm going to just start with letters. UW over YW, since the shapes are similar, is equal to another fraction. So VW right here, first and last letter, or second and last, sorry, corresponds to XW. All right, so on the diagram, let's actually plug that in. So that means I have UW is A over YW is 12 equals VW is 5 over 6.4. So I have a proportion and I'm missing a variable, so we cross multiply. Okay, cross multiplying again is when I multiply along the diagonals and I set the answers equal to each other. So A times 6.4, I'm going to write that as 6.4A. Set that equal to 12 times 5, which is 60. So divide by 6.4. So 60 divided by 6.4 is, 60 divided by 6.4 is 9.375. Okay, and that is the value of A. So if you can write a proportion, then you can cross multiply. Cross multiplying is typically a pretty easy way to solve an equation. All right, letter B. What is the ratio of the perimeters of UVW to YXW? Okay, so the ratio of the perimeters is the ratio of the corresponding sides right here. So it's basically the scale factor. So if I come back up here, I'm going to circle something in another color right here. This ratio right here is our scale factor. So if the ratios of the perimeters is basically that scale factor. So UVW does go with the 5, YXW goes with the 6.4. So I don't really want to leave it like that. It's kind of messy with a decimal within a fraction. So let's convert that into just like a regular fraction. So you could use your calculator, or what you could do is if you multiplied both by 10, so what I'm doing is moving the decimal over, I would get 50 over 64, and then I could reduce that down, okay? So this turns out to be a 25 over 32 ratio. That's I guess more of a cleaner fraction rather than a decimal within a fraction. So you could do it a number of ways. You could convert it to a decimal on your calculator and then go back to a fraction. Or like I did, I just multiplied bottom and top by 10 to move the decimal and then reduced. Okay, so that's the ratio of the perimeters. Okay, one more problem. And I want to review some solving here. Parallelogram ABCD is similar to parallelogram GBEF. Find all possible values of x. Okay, I need to write a proportion. I'm going to ratio corresponding sides. All right, so when I look here, GF, first and last letter, goes with AB, first and last letter. I'm sorry, AD. So I can put those two in a ratio. So I can say that 2x plus 5 in a ratio with 6x minus 2. Okay, and that's equal to, so probably the other two, but let's just check. So EF, last two letters, CD, last two letters. Okay, so 3x over 4x. All right, now when I go to solve this, I'm going to cross multiply. So, cross multiply. So I'm going to have 4x times 2x plus 5 equals 3x times 6x minus 2. And so I did that because I need to not only multiply the 4x by the 2x, but also the 4x by the 5. So let's distribute in. That's going to be 8x squared plus 20x. Distribute in over here. That's going to be 18x squared minus 6x. So I see x squared and x. So my next step is to get all the terms on one side and equal on the other. So because I want to keep 18 positive, or I want to keep x positive, I'm going to move the 8x over here. All right, so you need to subtract to do that. So I'm going to take away 8x squared from both sides. I'm also going to take away 20x. And so that leaves me with a 0. And that's going to be 18 minus 8 is 10, 10x squared. Negative 6 minus 20 is negative 26x. Now I only have two terms. So I see they both contain a minimum of 1x. So let's factor out of both terms a greatest common factor. So I not only can take an x out of both, but 10 and 26, I can take a number out. I can do a 2, but is there anything higher? No, I think 2 is the highest we can do. So 2x is what I'm going to divide out of both terms. So I am left with the first term, 5x. Because if I remultiply that, I'm back to 10x squared. And then minus 26 divided by 2 is 13. And there's no more x there because I already put it out front. So I am now going to still write two equations. So I'm going to set factor number 1 equal to 0 and factor number 2 equal to 0 and then solve. So when I divide by 2, of course I get 0. And then when I solve this one, I'm going to add over my 13, divide by 5. I'm just going to leave it as 13/5. Okay, so can they both be put back in the picture and have a positive length? So if I take the 0 and plug that in, see how if I plug a 0 in over here, I get a 0, which doesn't make sense. I have to have some kind of a length. So for this problem, I'm going to disregard 0 and just keep 13/5 as my answer. So there's really just one possible value here, and the possible value is 13/5. Okay. So don't forget, when we're dealing with shapes, you always got to plug back in to make sure that it fits and makes a reasonable number on your shape. Okay, that's it for this first section.